Hi, my name is Alan Olshansky. I'm an intern on the Android team, and today I'll be talking about image pixelization. I'll discuss a couple different variations of how you can achieve an image pixelization effect using some built-in operations and using some custom operations as well. Furthermore, I'll discuss the use of async task, which is an object you can use to offload work off of the UI thread onto a background thread, and then you can keep your UI completely responsive while doing so. One of the tricks that you'll see while you're doing the image pixelization effect is the fact that when we want to use some built-in operations, what you can actually do is downscale a bitmap and upscale it back up, and you'll see the use of a flag called filter, which we can use to vary between bilinear filtering and point sampling when we're actually doing the pixelization effect. So let's jump straight to the demo right here, and we just have an image of a couple of jellyfish, and moving this, as we move the seek bar from left to right, you can see that the image is getting pixelized more or less, but you can also tell that as my finger is moving, the seek bar is behind where my actual finger is. So there's a significant lag here. If we use async task, you can see that the image pixelization is exactly the same as it was before. It takes the same amount of time, but the UI remains completely responsive, and the seek bar never lags behind. If you look here, we can also use the built-in pixelization effect, which is significantly faster, and even though it's still on the UI thread, not on the background thread, you can tell that it's still keeping up to my finger exactly where it needs to be. So then jumping straight into the code and going down, there's some boilerplate code which you can look over later, and a simple seek bar listener to make sure that every single time that the value changes, we pixelize the image to get a new pixelized image on the screen. Scrolling down furthermore, we get to where the actual custom pixelization begins. So for custom pixelization, all we're going to do is implement this algorithm where you're going to loop through all the pixels in the image. You're going to average the values of the red, green, and blue channels within every single pixel to some value, and then you're going to set that same pixel value to all the pixels within that region. The key thing to note here is the fact that when you're retrieving or setting pixel values, you never want to use set pixel or get pixel if you know they're going to use more than those. There's a few methods available in the bitmap class, such as get pixels or set pixels, where you can immediately set an array of pixels or get an array of pixels, and it'll be significantly faster. So here we're getting the pixels, we're averaging everything out, and at the end we set the pixels in that bitmap. We then return a bitmap drawable, and then this bitmap drawable is applied to the image view, which you see on the screen afterwards. Now scrolling down furthermore, we move into the built-in pixelization effect. And like I said before, all this does here is we do a few simple calculations to determine what the downscaled width and height should be in order to achieve that pixelization effect. But the important thing is here, when we create a downscaled bitmap, we have to set the filter value to false. So what this does is use point sampling instead of bilinear filtering, so it doesn't actually average out the values of the pixel values around it, but it achieves this very blocky pixel effect that we're looking for. Going down here, so after we downscale it, we know that we need to downscale it back, upscale it back up. So before Jelly Bean MR1, the way we do this is simply create a scaled bitmap and upscale it back to the original width and height with that filter value to false. However, after Jelly Bean MR1, what you can actually do is create a bitmap drawable and with that image and set the filter bitmap to false. The thing is that before JBMR1, we always had the filter bitmap set to true for some optimization purposes. But what this lets you do here is not actually upscale the bitmap, simply set the filter, and then given that the image use scale type is fit XY, when we apply this bitmap drawable to the image view, what will happen is that it'll upscale it in a much more efficient manner to fit the whole screen. So here in invoke pixelization, this is the method that gets invoked every single time the seek bar is moved. And there's two different things that you can do. If the checkbox is checked to use async task, what we're going to do is initialize this pixelized image async task object and call execute with the appropriate parameters, which is the value of the seek bar and the bitmap that we're pixelizing. Moving into pixelized image async task, we can see that there's two main methods you always want to, two key methods you want to note. There's do in background and there's on post execute. So what happens when you call execute with the appropriate parameters, do in background is called on a background thread. it does the operations you can see performed here. And when this operation completes on the background thread, it calls onPostExecute back on the UI thread, where we simply set the drawable to what we want. On the other hand, if the checkbox was not checked, then we simply set the image drawable, and this is done directly on the UI thread, which is why we were seeing the laggy experience while scrolling the sequence as before. So that's pretty much it, and that's how you can do image pixelization and move things onto a background thread when you need to. Thanks.